Hello everyone, welcome to the session on energy engineering. I am Satish H, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. So this session we will discuss about the biomass gasification. So and what do you mean by the gasification process, and what are the raw materials for that, and then what are the combustion products that we get from this gasification process. As we were discussing various sources of biomass, okay, so and then the forms of biomass, okay, like there are like liquid fuels, gaseous fuels, okay, and as well as solid fuels, okay. So if you take the solid fuels, you have this the wood, that we can take it as a biomass solid fuel. And then if you take this ethanol, okay, which is produced from sugarcane, so that is an example for a liquid fuel, okay. So we have the gaseous fuels also, that is produced from the biomass through the process of gasification, okay. So this the fuel in the gaseous state. So we will discuss in detail about, okay, so what do you mean by the biomass gasification, and various reactions are involved, okay, combustion reaction, reduction reactions, and what are the typical reactions that are involved in this gasification process. So the product of this gasification process is carbon monoxide, hydrogen and methane, okay, that contains the energy that can be used for various applications. And later we will discuss about what are the different types of the gasification process, okay. So basically there are three types. One is a downward draft gasifier, and then upward draft gasifier, and cross draft gasifier, okay. With the help of the sketch we will discuss about that. To start with, in order to give the introduction to this biomass gasification, so it is a conversion process actually. So here the solid fuel is converted into the gaseous fuel, okay. So we take the input as the solid fuel, okay. So for example, wood chips, the wood chips is example for a solid like a biomass fuel, that is converted into the gaseous fuel, okay. So through the thermochemical process, okay, the heat is involved and chemical reactions are involved, combustion reduction process. Through this process, that solid fuel is converted into the gaseous fuel, and we need a device in order to for the gasification process. In order to convert solid fuel into the gaseous fuel, we need a device. That device we call it as a gasifier, okay. So gasifier is a device that converts the biomass to the producer gas, okay. Producer gas means that is the gaseous fuel. Biomass is like we are taking it as a solid biomass here, that is the input what we are giving to the gasifier, okay. So what are the different types of raw materials that can be used in order to produce this like a producer gas. Producer gas consists of the carbon monoxide, hydrogen or methane, okay. So what are the raw materials we need for that? So we know the equipment, that is the gasifier. The raw materials that are needed are the wood chips, okay. So and we need also like a coconut shell, okay. After de-husking of the coconut, okay, the whatever that material is remaining, okay, so that is a coconut shell. And then the straw, okay, that can also be used as a raw material in the gasifier, and as well as rice husk, okay. While processing the rice, you will get this rice husk, that can be used as a like a raw material for the gasifier in order to produce the producer gas, okay. And then there is a two, as I said, it is a thermochemical process. There are two like reactions that are involved. One is partial combustion and as well as a reduction. What do you mean by the partial combustion is like combustion with a surplus amount of oxygen, okay. So that is called as a partial combustion, okay. And reduction reactions are involved, okay. So what happens in the combustion process, okay. So the product of combustion are normally the carbon dioxide, okay. When this raw material when they burn, okay, so they will release these byproducts, okay, that is they release the gases. That gases are like, for example, if you take the wood chips and coconut shell in the gasifier, if you burn them, that will release carbon dioxide, and water vapor will be there, because that, for example, wood has certain quantity of moisture, okay, when you burn them, that will convert it into the water vapor as well, and nitrogen and carbon monoxide and hydrogen, okay. These are the byproducts when the combustion process takes place, okay. So when the solid biomass is undergoing a combustion process, these are the byproducts that are involved, okay. And then these are flowing through the charcoal, okay, so that will result in a reduction reaction, okay. So first what happens, what is the solid biomass is there, that will, the combustion reaction takes place, and that produces these byproducts, okay. So and then during this reaction, carbon dioxide and water vapor oxidize, okay, the char to form, okay. So what happens, oxidation, okay, will takes place, that will produce carbon monoxide, hydrogen and CH4, okay, that is methane. These gases are called as a producer gases. So this is about a brief introduction to that. So basically gasifier is a device which converts the biomass, solid biomass, into the producer gas. Like gasification is a process of converting solid fuel into the gaseous fuel, okay, and then there are like a combustion and reduction reactions are involved, okay, in the gasification process. And then coming to the what are the basic reactions that are involved in this gasification process is the carbon, okay, which is represented by C, and then reacts with oxygen, that is O2, that will form CO2, okay, that is called as a combustion process. If you take the wood, okay, it consists of a carbon content in it, okay, and then when it is burning, it uses the oxygen in the atmosphere, so in order to produce the carbon dioxide, that is released as a byproduct. And then this is a combustion process, it releases, okay, normally when you burn this wood, okay, you get a heat energy, okay, that means certain quantity of heat is released, okay, in the combustion process. So here 240 kilojoules per mole, okay, is the energy is obtained from that combustion process. The product of combustion of pyrolysis gases results in carbon dioxide and water, okay. So the product of combustion of pyrolysis gases, okay, so results in carbon dioxide and water. So the second reaction is the carbon again reacts with oxygen, okay, so in order to produce, okay, so 2CO, that is the carbon monoxide it will produce, okay. So that reaction is called as Bodold reaction, that utilizes the energy instead of giving out the energy, that is 1 minus 164.9 kilojoules per mole is the energy that is like utilized during that process. And then there is one more reaction next, that is water gas reaction. Again the carbon, okay, here also carbon is reacting with oxygen, here it is reacting with the hydrogen, okay. So that will produce carbon monoxide and then the hydrogen, okay. This is called as a water gas reaction, okay. So that because the water is involved, and then the like gases like carbon monoxide and hydrogen are produced, okay. So here also the energy is utilized, that is 122.6 kilojoules per mole is the energy that is utilized in this reaction. And then again we have carbon monoxide, which is produced in the previous reactions, again that will react with the water vapor, that will produce carbon dioxide and hydrogen. This reaction is called as a water shift reaction, that will produce, okay, about 40.2 kilojoules per mole, okay. If you burn 1 mole, okay, that will produce about 40.2 kilojoules of energy. And then the last reaction, that is in order to produce the methane, this is also called as a methane reaction, that produces 83.3 kilojoules per mole, okay. In this case what happens is, whatever the carbon we have, that will react with this hydrogen, okay, 2 molecules of hydrogen, so that will form the methane gases, okay. So this is the typical reactions that are involved in the gasification process, okay. So carbon reacts with oxygen in order to produce carbon dioxide, again carbon reacts with oxygen, okay, in order to produce the like carbon monoxide. Here there is a water vapor as well, So that will react with carbon, that will release carbon monoxide and hydrogen, and then carbon monoxide and hydrogen will react in order to give the carbon dioxide and hydrogen as well. Okay, so here the last reaction is methane is produced by combining this carbon with the a hydrogen gas. Okay, these are the typical reactions what are involved. Okay, so you have to remember what you mean by the gasification process, that is conversion of solid fuel into the gaseous fuels. Okay, so using the gasifier, that is a device that we are using, and what are the basic combustion and reduction reactions that are happening in this case of a a gasification process. Okay, so as I said before, there is a classification for this gasifiers. The gasifiers are classified as downdraft gasifier, updraft gasifier, and a crossdraft gasifier. Okay, let us see the one of them, that is the downdraft gasifier. This is the sketch that explains, that represents the downdraft gasifier. Okay, so what does it have? Like we have this a biomass hopper, where this biomass is taken in, and then this is open to the atmosphere. Okay, so here, for example, these the things which are you see in this gasifier. Okay, those are the wood chips. As I said, for the gasification process we need a raw material as the wood chips. Okay, so and then we have air is also taken at this point as well. This is called as a air nozzle. Through this nozzle, air is taken inside. Why we need the air? For the combustion process, we need the air. Without oxygen, the combustion doesn't take place. Okay, so here the air is taken at this point. Okay, and then we have this after burning, the wood chips after burning. Okay, the ash is produced as a byproduct that is collected on this grate. Okay, grate grate. Okay, it is a a platform in order to collect this ash which is produced from this a wood chips. Okay, and then at the bottom we have a water seal. Okay, so that the air doesn't producer gas doesn't escape downwards. So and then we have this gas out. Okay, so here we take out the gases, that is the producer gases, that is what we are looking for. Okay, so this is the input, that is the wood chips are the input, so the solid fuel is the input, and then the gases out, that is a producer gas, that can be so methane, or carbon monoxide, hydrogen. Those are the gases we are coming out. Okay, those gases can be utilized for the various applications. Okay, and then we have this annular jacket. Annular jacket. After this, all the reactions, those producer gases will escape through this one. Okay, so and then for the passage, for the flow of these producer gases, we have this annular jacket. That is between this insulation and then the this gasifier inner wall. Okay, so again in order to contain the heat, we need a insulation. That will increase the efficiency of the gasifier. So what is the hatched portion here? So this is the insulation we have. So on the both the sides it has been insulated. So and we have this producer gas, which is when it comes out here, and then it can go through this passage here, and then here it will come out as a producer gas at this point. Here you can tap the producer gas here. So this is about various components of this the gasifier. Basically what we have is, we have the raw material, we taken the wood as a raw material, and then we have taken it into the through the hopper into the gasifier here. The gasifier is surrounded by the annular passage, or the annular jacket, around which we have this the insulation. So at the bottom, in order to collect the ash, we have a grate, and then water sail at the bottom we have. In order to gas to pass through, so we have a annular jacket, through which the gases are passing. So let us discuss what are the different reactions we have. So here we have we divided the this whole gasifier into the zones. So before that, so why it is called as a downdraft gasifier is, so here the wood chips are like we're taken at the top, and then they are flowing in the downward direction. And then the heat and the heat that is released, okay, so that is produced like going in the upward direction, that will take out certain amount of moisture from this wood chips as well, okay, that will increase the efficiency of this gasifier, okay. So coming back to the different zones that has been divided, so we have the first one is a drying zone, that is at 350 degrees centigrade, and a little bit below that one we have a pyrolysis zone, okay, that is 350 degrees to 600 degree centigrade, okay. So and then below that we have what we call it as a combustion zone. This is a oxidation zone, that is having a temperatures of 100 to 1000 degrees centigrade, very high temperatures. Below that we have a reduction zone, that is about 100 to 1000 degrees centigrade, okay. So that means to say we have divided that into the 4 zones basically. One is drying zone, pyrolysis zone, oxidation zone, and reduction zone, okay. What happens here, okay, in the case of when these wood chips are here, okay, here the air is taken inside, so the wood chips which are dried by the time it reaches at this point, okay, so they will combine with the oxygen in order to produce a product of combustion. Normally the product of combustion are carbon dioxide, water, nitrogen, and then the carbon monoxide, okay. So again these the combustion products, okay, so they will, okay, again undergo the reduction reactions, okay. So these are the reduction reactions here. It will combine with water, okay, and then carbon dioxide, okay. So in order to perform like a hydrogen, carbon monoxide, and CH4, okay. So at this junction here, this is a reduction zone where the temperature is in between 100 to 1000 degrees centigrade. The product of combustion from this oxidation zone, okay, the product of combustion, they will react again with the char, okay, or the carbon in order to produce the producer gases. Once those producer gases are produced, okay, they will, okay, escape into this annular ring, okay, and then they go out here, okay. So here there is a purpose of providing this annular ring, okay. When the gas is moving, okay, in this direction here, so it has a very high temperature, okay. So the heat is transferred, okay, from this hot gases, okay, to this like a wood chips, okay, which are taken at the hopper here, okay. So that means to say that high temperature will help us to remove the moisture content in the wood, okay. So that help us to remove the moisture content in the wood, okay. So that will increase the efficiency, okay. That is the reason why we are taking the like a producer gas, okay, through this annular ring and then taking it at the at the gas outlet here, okay. So this is about the downdraft gasifier, okay. So it is basically an arrangement where the solid fuel, that is the wood chips, are converted into the producer gases. That is, producer gases means, okay, so carbon monoxide, hydrogen, and CH4. So how does this is produced? Through this reduction and oxidation and reduction process, okay. So and then drying, and then the pyrolysis zones are there, so where the solid fuel, that is the wood chips, gets dried, okay. So that will also increase the efficiency of the gasification, okay. So this is about the brief introduction to this, what do you mean by the biomass gasifications, okay, and then what are the different reactions that are involved here, okay, typical reactions for gasification process, as well as we have a with a sketch we understood that what do you mean by this downdraft gasifier as well, okay. So next we will discuss other 2 types of the gasifiers. Next we will discuss about other 2 types of gasifiers. So that is updraft gasifier and as well as a crossdraft gasifier, okay. As I told you before, gasifier is an equipment that converts solid biomass fuel into the gaseous biomass fuel, okay, through the thermochemical process, okay. So both oxidation and reduction process are happening, so that will produce the producer gases, that is hydrogen, okay, methane, etc. So let us look at this the construction and working of this updraft gasifier. So here the construction is similar to the like a downdraft gasifier itself. Okay, so we have the gasifier, and then at the top we take the biomass, okay, into the gasifier through this hopper. Okay, so and then we have the outlet is provided at the top. Okay, so and then inlet of the air is provided at the bottom. Okay, so that means to say the air moves from the bottom of this gasifier to the top of this gasifier. Okay, so that is the difference between, okay, downdraft and updraft gasifier. Okay, so and then the raw materials, okay, as we know that for the gasification process the raw materials are wood chips, okay, so are straw, okay, etc. we can take into the like a gasifier with the help of this hopper here. Okay, so and then we have this grate above which this biomass is stacked, and then the ash which is coming from this like after the combustion, okay, and reduction process, okay, it is collected at the bottom of this gasifier here. Okay, so coming to this one, we have the various zones. Okay, so in the gasification process, so here the wood chips here, and then drying zone at the top of this one, and then we have a pyrolysis zone, and then we have a reduction zone, and then the oxidation zone. Okay, so what happens in the case of a oxidation zone? Okay, so the combustion products, okay, or the combustion zone or oxidation zone, the carbon dioxide, hydrogen, okay, or water, okay, and the carbon monoxide are the products of this oxidation process. These the products of the oxidation or the combustion will undergo reduction process, okay, with the char in order to produce, okay, the producer gases like carbon monoxide, hydrogen, and methane. So after this the air, okay, or the producer gases will move in the upward direction. So where the pyrolysis is above this reduction zone, in the pyrolysis about 70 to 80% of this the mass of this biomass or the wood chips is lost. Okay, and then above which there is a drying zone where this the wood chips or the biomass which is taken into the gasifier loses the moisture. Okay, it is getting dried. Okay, so it loses maximum moisture because of the temperature, okay, of this producer gases which are going up. Okay, and then finally the gas is taken out, okay, at the outlet, okay, at the top of this gasifier. Okay, so this is the working of updraft type. So compared to the downdraft type, the efficiency of this gasifier is more because we take the air at the bottom, okay, and then whatever the temperature is there, it is utilized for the pyrolysis and then the drying of this biomass, okay, taking out the moisture. So the efficiency of this like a updraft type is more. Okay, and also one more important advantage is it is very simple to construct and easy to operate. Okay, so this is about the updraft type of a gasifier. Okay, so next one is, okay, the crossdraft. So in this case what we have is we have this biomass offer, okay, so through which this biomass is taken into this gasifier, and then we have this like a grate upon which this biomass is stacked, okay, or collected, and we have this the space at the bottom which is provided for the collection of the ash after this combustion or burning process is taking place, and then we have the air is taken at this point here, and then immediately at exactly at the opposite end, okay, so we have the air is going out, okay, that means the gases are taken in, the air is taken in, and then the producer gases are going out at the opposite side of this gasifier here. Okay, so that is why it is called as a cross draft, because across where it is the air is taken in, okay, so exactly opposite to that there is a outlet, okay, through which the gases are taken on. Okay, so similar to the other gasifiers where the biomass is converted into the like a gaseous fuel, here also the wood chips, the solid biomass is taken. So and then the zones, okay, so the different zones as we discussed before, so here also we have the same thing. So we have the reduction zone, okay, and then the hearth zone, or it is also called as a combustion zone and burning of the char, okay, and then we have a pyrolysis zone, and then drying zone, and then the wood chips, okay. Those are the raw materials for this, okay. So for coming back to the working principle, how does it work, okay. So we have this, the biomass, through the biomass hopper, the wood chips are taken into this the gasifier, that is crossdraft gasifier, and then the air enters at this point, and then here itself both oxidation and reduction process are happening, okay. And then after this, whatever that producer gases that are produced, okay, are taken out at this point, okay. So above this reduction zone there is a pyrolysis zone, okay. The pyrolysis zone, whatever the heat of this producer gas, okay, so that will make the weight of this biomass, normally wood chips, lose by about 70 to 80%. The weight of the biomass chips, okay, so like it decreases about 70 to 80%, okay. Above which we have a drying zone where the biomass is, okay, dried, okay. So the maximum amount of moisture is taken out from this biomass, okay. So and then whole of this gasifier is is insulated in order to increase the thermal efficiency. That means in order to prevent the loss of heat, okay, to the atmosphere, okay. So what happens in the case of a combustion zone here is, okay, the products of combustion, that are the gases which are formed, are carbon dioxide or water, okay, or nitrogen, carbon monoxide, and then hydrogen. Those are the products of combustion, okay, are the products of burning of the charge at the hearth zone. And then after this product of combustion combines with the, okay, the char again, okay, so that undergoes the reduction reactions in order to produce the producer gases, okay, that is a gaseous fuel from the gasifier, okay, that is carbon monoxide, and then hydrogen, and then the methane. This carbon monoxide, hydrogen, and methane can be utilized for the various processes, okay. So that is about the crossdraft gasifier, okay. So there are three types what we have discussed. One is downdraft, and then updraft, and then the crossdraft, okay. So in the downdraft type, what happens is the air is taken at the bottom, and then the air, the gases, that is producer gases, normally containing carbon monoxide, hydrogen, and methane, are taken at the top, okay. So this is simple to construct, and the efficiency of this gasifier is more because so the air is moving in the upward direction. So while moving in the upward direction, the producer gases has a temperature that will help to pyrolyze the pyrolysis of this, or the reduction of the weight of the biomass, as well as drying of this biomass will be taking place, okay. So and then similarly we have the various zones, okay. So oxidation zone, where the products of combustion are formed. That products of combustion, okay, so will again combine with the char in order to produce the producer gases, carbon monoxide, hydrogen, and methane, okay. So above which we have a pyrolysis where the weight of this biomass is reduced, and drying zone where the moisture, maximum amount of moisture is taken out from the biomass, and then the producer gases are taken out at this point, okay. So in the crossdraft gasifier, what we have is the similar setup actually, but instead of the outlet, okay, the gases or outlet is shifted to the exactly opposite to the where the air is taken in, okay. So that is why it is called as a crossdraft, okay. The air will flow across this gasifier. So here also we take this biomass through the hopper, and then we have that combustion and reduction process are happening at the almost same location, okay. And then whatever is the air taken in, that is the producer gases are going out at this point, okay, where this outlet is there, okay. So and then similarly it has the zones like reduction zone or the combustion zone, okay, and pyrolysis zone, and then the drying zone, okay. So here also in the combustion zone, okay, the combustion products are formed, and then in the reduction zone, that will again react with the char in order to produce the producer gases like hydrogen, carbon monoxide, and methane. And then the pyrolysis, where the weight loss of this like 70 to 80% of this mass of this biomass reduces, and then the drying zone where this the moisture is taken out. Okay, so this is about the gasification process. So we have discussed what do you mean by the gasification, and then like it is conversion of solid fuel into the gaseous fuel, and then what are the general reactions that are involved in this gasification process. The two reactions are the combustion or oxidation process, and then the reduction process we have. Okay, so oxidation is like a controlled combustion in the surplus air. If the combustion takes place, that is called as oxidation. Okay, so and then we have discussed about three types of important types of gasifiers. One is like a downdraft gasifier, updraft gasifier, and then a crossdraft gasifiers. Okay, so this is about the gasification process. Gasification process is the method of converting the like a solid fuel into the gaseous fuel. Okay, so in the biomass. So thank you so much.